Hello students, in this lecture we'll see a problem on bilinear transformation. A problem is find the bilinear transformation which maps z is equal to infinity I 0 into w is equal to minus 1 minus I 1. Also find fixed point of the transformation. Solution. So the given thing, so given values of z and w we have to collect it. So we have, so z values are infinity, I and 0, and w value is minus 1, minus I and 1. So these are the values of z and w. So as we know that our w, that is omega, is given by, it is az plus b divided by cz plus d. So this is the formula for our means w. So we'll give this as equation number 1. So in this w is equal to az plus b divided by cz plus d. We'll apply the values of z and w, and we are going to generate equations, and those equations we will solve it and we'll get complex constants, that is a, b, c, d. So let's see here. So here so z1 value is infinity and z2 value is I and z3 value is 0, and similarly w1 value is minus 1, w2 value is minus I and w3 value is 1. So using this z1, z2, z3 with respect to w1, w2, w3, we'll apply in equation number 1, and let's see the equations here. So the equation 1 becomes, that is w1. So equation 1, so take z1 is equal to infinity and w1 is equal to minus 1. So we get equation 1 becomes, that is minus 1 is equal to a into z value is infinity, so a into infinity plus b as it is, c into infinity plus d. So you observe here, so a into infinity, that is again will get means will not get a correct result. So as well as c into infinity will not get any definite results. To get a definite result, so here, so this z is equal to, z1 is equal to infinity will not apply. So for that, so I will rearrange the equation 1. So on rearranging the equation 1, on which is, I will write here, which is not definite result. So therefore what we will go for, on rearranging 1. So what is 1 here? So on, so here what we'll do, so infinity, how to make infinity value as 0? So we have to make 1 upon z as 1 upon z, so that 1 upon infinity is nothing but 0. So we'll rearrange for that. So for among the numerator, so among the numerator and denominator, take z common. If you take z common among this, it will become a plus b upon z. So therefore on rearranging 1, so omega or w is equal to, I will take z common in the numerator of equation 1. So if I take z common, it will become z into a plus b divided by z. Similarly take z common in the denominator also. So if you take, so it will become c plus d upon z. So now, so this z cancels. So w is equal to a plus b upon z divided by c plus d upon z. Now we'll apply z value as infinity and w value as minus 1, and let's see the result now. If you apply, so therefore it will become minus 1 equal to, so a plus b upon infinity divided by c plus d upon infinity. But just see that a plus b upon any value upon infinity is always 0. So therefore it is a plus 0 divided by c plus again d upon infinity is again 0. So we got minus 1 is equal to A upon C, or on cross multiplying we'll get A is equal to minus C. So we'll get A is equal to minus C. So or I can say that A plus C equal to 0. So we got an equation number 2 from Z1 value and W1 value. Now take W2 is equal to minus I and Z2 is equal to I. Equation 1 becomes that is I minus I equal to bracket A into I, because Z value is I. Okay, so A into I plus B divided by C into I plus D, or it will become I A plus B divided by I C plus D. So cross multiply this IC plus D to the left hand side, so we'll get as, so minus I into IC plus D is equal to IA plus B. So on rearranging or opening the bracket, minus I into I is minus I square of C, minus into plus is minus I into D is ID, is equal to IA plus B. Or on rearrangement, so this minus I will rearrange in alphabetically, shift this all to the right hand side, so it will become IA plus B. So this I square is minus sign, so I square is minus 1, that minus this one will become plus, so that plus C, if you shift to the other side it will become minus C, and this minus ID, if you shift to the other side it will become plus ID equal to 0. So we got equation number 3 by W2 and Z2 value. So now again we have to apply one more last value, that is take W3 is equal to 1 and Z3 is equal to 0. So if you apply these values in equation number 1, what happens to equation 1? We'll see. So equation 1 becomes, that is 1 is equal to A into Z, that is 0 value, plus B divided by C into 0 plus D, which is nothing but B upon D. So on cross multiplying it will become D is equal to B, or we can write B minus D equal to 0. So with the help of this equation 2, 3, 4. So equation 2 is, we got this, equation 3 and equation 4, we have to get the value of A, B, C and D values. So let's see how to get the values of this A, B, C, D, which is nothing but a complex constants. So therefore, for simplification we have to go many arrangements. You can see that our equation 2 is having only 2 terms, that is A and C. Equation 3 having A, B, C, D, all 4 terms, but equation 4 having what here? Only B, D. So if you compare with the 2 and 4 also, so 2 and 4 is completely different only, because no common term is there, so we can't use 2 and 4, as well as 2 and 3 also we can't. So in that cases, so what we'll do here, so I will go for one addition arrangement here. That arrangement is, I will take it as, now we'll make 2 plus 3. Okay, so we'll make 2 plus 3. What we get, we'll check here. So anyhow, so you whatever situation you take, no problem, but see that at the end we have to going to get values of A, B, C, D. Okay, so I'm taking an option 2 plus 3. So what is 2 here? So 2 is A plus C, and 3 is this entire, that is IA plus B minus C plus ID is equal to 0. So therefore what happens, I will take 2 first. So 2 is A plus C plus, and 3 is IA plus B minus C plus ID, and equal to 0 as it is. Left hand side added with left hand side, right hand side with right hand side. So on rearrangement you can observe that we have A and IA. So among this I will take A common, so we'll get what here, 1 plus I of A. Then b is alone, write plus b. So c plus c and minus c is there, so which will going to be cancelled. Fine. So then what left here? id, that is plus times id equal to 0. So I will make this as one more equation and give the name as phi. So phi is very important to get what here, equation a b c d value. Now you can see that equation 4 what we have, it is b minus d. So equation 5 is also having b and d. So here in equation 4 a is missing, so we'll make equation 4 0 into a, then b minus d, and equation 5. So on solving 4 and 5, on solving 4 and 5, we get so on solving 4 and 5, so 4 can be written as here, I will write it as 0 into a plus b minus d equal to 0, and our equation 5 is nothing but what here, 1 plus I of a plus b plus id equal to 0. So if you simplify these two, okay, you can observe here, so we are going to be cancelled, so we'll change the sign, minus minus minus, so plus b minus b cancels. Okay, so what we are going to left, you can check, or else we'll go for other option here, we'll go for other option. I'll rewrite on solving 4 and 5, so what we'll get here, fourth one is 0 into a plus b minus d equal to 0, and from equation 5, which is 1 plus I of a plus b plus id equal to 0. So again I will go for cross multiplication. So by cross multiplication method, so what happens here, so a divided by determinant, which is equal to minus b divided by determinant, and we have the variable d here, so d divided by determinant. So therefore if you want to find the determinant of a, we have to hide this a, so we have to take these 4, b minus d, b and plus id. So coefficient of b is 1, coefficient of d is minus 1, coefficient of b is 1, coefficient of d is plus I. Similarly, to get the values of b, we have to hide b, so 0 into a minus d, 1 plus I into a and id. So coefficient of a is 0, coefficient of d is minus 1, coefficient of a is 1 plus I, coefficient of d is I here. So similarly, to get the value of d, so we have to hide d, so we have to take 0 into a, b, 1 plus I into a and b. So coefficient of a is 0, coefficient of b is 1, coefficient of a is 1 plus I, and coefficient of b is 1 here. So we got this determinant, so we need to simplify. So let's see the simplification of this determinant. So that a divided by, so 1 into I is I, formula minus 1 into minus 1 is plus 1 into this minus is become plus 1, which is equal to again minus b divided by 0 into I is 0, formula minus this minus 1 into this will become plus of 1 plus I. Again d divided by 0 into 1 is 0, formula minus 1 into this bracket, that is 1 plus I. So therefore, which is nothing but, so on simplification again, so you can observe here, so I will rewrite all the things, a divided by I plus 1, which is equal to, if you simplify this, so what happens here, b divided by minus times I plus 1, this bracket I am writing, and which is equal to d divided by minus times I plus 1. Fine. So all the denominators having I plus 1, so you just make divide I plus 1 for all three. So what we are going to get here, a divided by 1, b divided by minus 1, c divided by minus 1. So therefore Therefore, which implies the value of A is 1, value of B is -1, and value of C is -1. So we got A, B and C value. So we are going to get one more value, that is D. So any means to get the value of so this is the D here. So we got the value of D. So A, B and D we got. To get a value of C, so you can use equation number 1. So you can use your equation number 2. So from 2 to 2 is A plus C equal to 0. So value of A we got 1 plus C as it is equal to 0. So which implies, so C is equal to -1. So we got the value of C also, that is -1. So therefore finally I can say that finally the value of A is 1, B is -1, C is -1 and D is -1. So we got A, B, C, D. So we have to substitute these values in equation number 1. So on substituting in 1, so what happens we'll see. So it will become W is equal to A value is 1, so 1 into Z plus B value is -1 divided by CZ. C value is -1 into Z plus D value is -1. So which is nothing but Z -1 divided by -Z -1. Or you can rewrite this one as, so if you take a minus sign common here, okay, and take minus sign common in the numerator. So minus of 1 minus Z divided by, if you take minus, so it will become 1 plus Z, minus cancels. We get 1 minus Z divided by 1 plus Z. Okay, so this is nothing but the W value, which is purely in terms of what here, Z. So but in the question they have asked find the fixed point. So fixed point is also called invariant also. Let's see that one also. So now to find fixed point, which is also called invariant. So they may ask you to find invariant point also. So you have to remember to find fixed point or invariant. So for that we are going to use again the above previous result here, that is image, that is W is equal to 1 minus Z divided by 1 plus Z we are going to use. So here what happens to check to get that one, so put W is equal to Z in the above expression. So if you put W is equal to Z here, so what happens we'll see. So Z is equal to 1 minus Z divided by 1 plus Z, means equation will get in terms of purely in terms of Z. So multiply this 1 plus Z to the left hand side. So Z into 1 plus Z is equal to 1 minus Z, or on opening the bracket, so it will become Z plus Z square, and take this inside. So minus 1 plus Z equal to 0, or on rearrangement, so Z square, Z plus Z is 2Z minus 1 equal to 0. So we got the expression for this. This is nothing but what here, Z plus Z square. So this is a quadratic equation in terms of Z. To get the value of this Z, so we'll apply what here, a quadratic rule. So that quadratic rule is, so I will show the manual result, or else you can go for the calculator also. So this is a quadratic equation, so which is not going to be simplified directly. So I will use the formula method. So Z is equal to, so here B value is 2. So formula says minus B, that is minus 2 here, plus or minus square root of B square. B square is 2, so 2 square, that is 4, minus 4 times it is 2 ABC. So 2 ABC, A value is what here 1, B value is 4, so it will become 4. Okay, and C value also. So at that time you can 2 BC value. So at that time you can see that C value is minus, so it will become plus here, divided by 2 into 1. So on simplification, minus 2 plus or minus square root of 8 divided by 2. So finally on simplification, z is equal to minus 2 plus or minus 4 square root of 8 can be written as 2 root 2 divided by 2. So which is nothing but, if you take 2 common, so 2 you common, so it will be minus 1 plus or minus square root of 2 whole divided by 2. So 2 cancel here. So z is equal to minus 1 plus or minus root 2. So this is the value of z. So we can say that, so this is invariant points or fixed point. So therefore the fixed points, or in bracket I can write it as invariant point is nothing but minus 1 plus root 2 and minus 1 minus root 2. So these are the invariant points or fixed point for the given bilinear transformation.